In our first video about footings, we covered the basic principles of footing technology. In this animation, we will be focusing in more detail about the many different kinds of footings available today. The conventional raft system is a grid of concrete beams with steel inside that supports a concrete slab. The combination of a grid of concrete beams and an integrated slab on top is designed to form a rigid platform that resists the movement of the reactive clays underneath. Trenches are dug into the ground to form the grid shape in which steel is placed and concrete poured into to create the footing system. Pros: most common footing type for brick veneer dwellings. Great for reactive soils. Good on low-bearing soils. Has an integrated slab. Cons: more expensive than Grillage Raft due to additional steel reinforcement and concrete. The Grillage Raft system is much like the conventional raft. However, the beams are slightly narrower, deeper, and contain less concrete and fewer, but larger steel bars. A Grillage Raft has a more efficient design, but can be more difficult to construct due to the deeper and narrower beam. Pros: good for reactive soils, cheaper than conventional raft due to less concrete and steel, suitable for sites with lower reactivity, has slab on top. Cons: not appropriate for low-bearing soils or collapsing sands, sites with shallow rock, sites with loose fill. The Waffle pad footing system is a grid of relatively narrow concrete and steel beams formed entirely above the ground using styrofoam boxes as formwork. Boxes vary in height from 225mm to 400mm depending on the soil reactivity on the site. Pros: cheaper than conventional raft due to less concrete and steel. Suitable for sites with lower reactivity, little or no excavation required. Cons: not good for highly reactive sites. Can create floor level issues. Can be visually unappealing. The block footing system is a series of concrete blocks that are stacked and bear either directly onto firm natural ground or on concrete pads that bear onto firm natural ground. Pros: very cheap, minimal excavation and earthworks. Good for non-reactive sites and transportable houses. Cons: only suitable for lightweight timber frame dwellings. Not good for reactive sites. Floor level will be higher than outside ground level. A strip footing system uses concrete beams with steel reinforcement. Beams can form a grid if desired to improve overall strength of the footing system. Generally used to support a continuous wall or a dwelling with timber floors, similar to block footings but with more strength to resist soil movement. Pros: cheaper than conventional raft footings. Cons: does not have a slab on top to construct level flooring. More prone to movement than slab footings. The pole frame is a series of poles ranging from 0.7 meters to 3 meters that support a generally lightweight structure above. Pros: good for steep sites, minimize earthworks on steep sites, allows for construction on normally unbuildable sites due to slope. Good for sites with shallow rock. Cons: generally only suitable for timber frame dwellings and therefore not energy efficient. Aesthetics not great depending on preference. Not good for reactive sites. The poles bear onto a concrete footing. A close-up of the pole explains how it is supported on the ground and sits on the concrete footing. The basic slab on ground is a concrete slab with steel reinforcement. This is only used for highly flexible structures such as sheds on less reactive sites. The slab on the ground is not designed to resist soil movement. Pros: very cheap, minimal excavation required. Cons: not good for reactive soils. Isolated pad footings are concrete pads with steel reinforcement, used to support single columns rather than continuous walls. Pros: very cheap, minimal excavation required, useful for isolated posts, pergolas, verandas, etc. Cons: not good for reactive soils or movement-sensitive structures. For further details on footing design, please contact FMG Engineering.